Hi, my name is Ruth and I'm your course teacher for CSE 302 System Analysis and Design. Now we've taken a couple of classes already, but due to the accreditation there was kind of sudden break. So I've decided to make this recording to enable you to go through some of the pending lectures or pending classes that we haven't taken. Now I've already touched majority of the course outline, but I'll look at critical areas where practical knowledge is required, and I'll be demonstrating it where necessary. Now the last class, if I remember correctly, we had was that of analysis and facts gathering. Now I've already prepared the slides for almost all the topics, and we'll be sending it to you to get alongside with this video, so you're expected to read through thoroughly while you're enjoying your Christmas or your New Year holiday, and get questions prepared so that when we resume we can just brush through and do a quick revision. All right, I'll start with data delivery, which I've already prepared the outline, and that should be lesson, let's see if it's lesson 3. Sorry, you need to read up lesson 3 yourself. I wouldn't be teaching on that. It's quite straightforward. So let's go to this. Also, you're supposed to read through lesson 5. Gives us what's the topic? Yeah, this is what I'm looking for: data delivery. Now the objective of this class is that you should be able to highlight and explain the data delivery document and documentation in software. Now this is extremely important. Now when we talk about data delivery, we are talking about making the required data or information concerning your project available to the required people. For instance, when you get a product, like let's assume that you just make a purchase of a new mobile device, there is usually what they call a user guide. Now that is a documentation that is required in software development. That is, anytime you are producing any kind of software, there are certain documentations that are required. This will include manuals, logbooks, user guide, manufacturer document, and most importantly, agreement document. Now agreement document is very important because agreement document covers every phase of the software development life cycle. Now at the beginning we talked about the different models of software development life cycle. So whichever model you're using, is important that the moment you agree with the stakeholders in respect to a phase, let's say at the conception stage, when you meet with the stakeholders and you've come to an agreement as regards to how the software should look like, a document, what we call an agreement document, is usually created, which is signed off between the team members and the stakeholders. So it's very important. As a software project starts and progresses, the software project team is required to produce agreement stating what has been agreed upon, the deliverables, and that is important because if you don't have deliverables, that means you cannot ascertain if the software, if the project is successful or not, because at the end of the day, the testing will be done. The testing of the software is usually done against what we call the deliverables, which translates into the system requirement. Now, data on completion, I've already said that depending on the model you're using. Okay, now what you're expected to do is a very short, what you're expected to do now, based on what has been done, is for you to write up. Remember, you have topics, so you're expected to have done to work to a reasonable extent. So for each stage, you need to assume that you are producing for a stakeholder, and then come up with an agreement, just a one-page agreement for the phases that you've covered, for conception, for the analysis stage, for your design stage, and then of course the implementation, and so on and so forth. All right, now let's quickly go to the main and one of the most important aspect of it, what we call case. Now when we talk about case, I've already introduced you to a couple of tools or software that enable you to do analysis and design of your software, but today I will just give you more a better guide on what you're supposed to do, just in case you are not too familiar with it. Now, case is for what? Computer-aided software engineering. Now, the main objective of this class is that you should be able to explain what case is, and of course use common tools for software development. Now, when we look at the case, or as you can see, it stands for computer-aided software engineering. That means you are using a computerized or a computer or a tool or a software or an application that enables you to do your analysis and the designing of your software project. So it's actually computerized. Your implementation, you use a tool. For example, if you want to code, you must use an IDE. Whether you are using, no matter the programming language you're using, of course it's easier to use an IDE than going through the raw coding using maybe Notepad. Even the Notepad itself is actually a tool. Then of course we are talking about design. The designing, of course, you know what a design is. You are using pictures to represent your requirement, all your interface, and so on and so forth. Your analysis is very important because it's there that you identify the specifications of the requirement of your software, and those things also, you can use pictures or you can use flowcharts or pseudocodes, as the case may be, depending on the methodology you are using. Of course, methodology is way out of this course, so I won't be talking about that. Okay, now case tools are set of what? Software application programs which are used to automate the SDLC activities. I've already explained that. So there are several activities like your conception, analysis, your design, implementation, testing, and so on and so forth. All these are actually activities. Then several tasks makes up this activity. So it's not that because it's called an activity does not mean that you just do one single thing and that is done. No, you do several things that makes up what? Analysis. Because if there, for instance, in your analysis stage, you must identify your users and your use cases. That is an activity or a task. You should also be able to identify your system requirement and specification. That also is a task. So all of that makes up your what? Your activity. Okay. I'm not supposed to read that, so you're supposed to read it. My responsibility is to do the explanation. Now, why do we use computer-aided softwares or engineering tools? That is because it helps to accelerate the development of project to produce a desired result, and helps to uncover what flaws before moving ahead with the next stage in software development. Computer makes life easy. So instead of me to use pen and paper to keep drawing, and every error I have to cancel or clean and keep doing that, I can use the computer. Makes life easy. So you can use several of them. Now, the components of case, you have the central repository, which means that when you design, you can save it and you can recall it back. Of course, it gives you the opportunity to also use the uppercase and the lowercase, especially when it has to do with when you are identifying what we call variables. Okay, we know the rules of how variables should be written. A variable has to start with the uppercase. A class needs to start with the uppercase, so you can't just write it anyhow. So it gives the tools enables you to use all of them. It has provision for all of this, and of course there is what we call integration. When I design, if for example I'm designing a project and I'm supposed to have a class, okay, it gives me opportunity to identify, to type in to put in the name of the class, the various attributes, or rather variables, and then the methods also. The blocks are already stated, so I can have something like a triangular shape and then put each of them appropriately. Now this will be demonstrated when we get into the next chapter, where I'm going to show you how to actually use some of these tools. Okay, then let's go on. We've talked about, of course, it helps us to model. You know what a model is? It's representing the actual project, all right, using symbols and so on and so forth. It helps us to also manage the project, because you see, every software has a start time and it should have an estimated end time. So with the computer-aided application or software tools, we are able to say that, okay, we are starting at this time, and then there is a management, what do they call it? A management possibility, in the sense that we can actually put all our activity, give a time frame to every activity. For example, I can say that I want to use 1 week or 2 weeks for my conception. I want to use 3 days for my analysis phase. I want to use 7 days for my design stage, and of course the implementation could be 40 days, 30 days, 60 days, as the case may be. So there are tools for it. If you go through, you know, the internet and even go and type in software development management tools, there are a series of such that enables you to do that. Then the documentation tools. Now for each of these, if you look at it, for each of them there are examples of tools that you can use. Now let's look at it. For example, for diagram, you can use a flowchart maker. Okay, you can even Microsoft Word, you can use it, although it's quite challenging using Microsoft Word because of the way Microsoft is not primarily designed for software design, but you can actually use it. Now if you go to process modeling, you have the EPF composer. All right, you have that. These are just some of the examples. Okay, ProOffice is an example. Basecamp also is an example for what project management tool. And if you go to documentation, you have Adobe DR Explain. There are several of them, but of course I cannot recommend a particular one because it has to do with how conversant you are within the environment. That's number one. Okay, does it really have the tools that you really need? And of course, is it free or proprietary? If it's free, that means you can download it and use it for a period of time, or you know, depending on the, but if it's proprietary, it may be you can only use a trial version for 7 days, or you get the actual one by paying some money. But there are always free versions of all these tools, so all you need to do is to search for it and then use the one that is available. Sometimes you can even do it, use the online. That means that I don't need to download it. I just so far as I have access to internet, I can use these tools. Your analysis, you have it here. Your design for animation and so on and so forth, you have it there. All right, then of course the configuration. These are things that you need to read up. Programming to NetBeans, prototyping, you have the actual stuff there. Okay, then for web development, you have brackets, you have Adobe Edge Inspect, and several of them. Even Dreamweaver falls under this. You don't need to really type a single code. Then of course you have the SOAP test, AppsWatch, JMeter for your what, for quality assurance tools. For instance, if you want to test the quality, how robust, how viable your software is. You can use the software, quality assurance to check it up, then maintenance. Now you're expected to go online, okay, and at least learn 3 of these tools, learn how to use them, play around with it. It's not a rocket science. It's quite easy for you to learn, but you must be willing to spend probably 45 minutes to an hour, for maybe a period of 3 days to enable you get yourself familiarized with each of the tools. Now we will go into some serious work, which I'll call data flow. Why? Because this is the crux of the matter. This is a very, very vital aspect of software development, system analysis and design. Now, data flow diagram, commonly known as a DFD, is very common and falls under what we call the we use it a lot in the structured system methodology. Okay, that's where you can use it together with flowcharts, pseudocode, and so on and so forth. But for object-oriented, if your approach or your methodology is object-oriented, you don't really need data flow diagram. What you need is class diagrams, sequence diagrams, state diagrams, and so on and so forth. But let's look into data flow because it's about the commonest that people use, because you are introduced to flowchart, you are introduced to pseudocode from, I think, year 2 or thereabout. So it's something you're already familiar with, so we'll stick to that. Now the objective is that you should be able to discuss the concept of data flow diagram and apply the knowledge for analysis. That's what you're supposed to do. Now, what is data flow diagram? It's a traditional visual representation of the information flows within a system. It shows how data enters and leaves the system. Now, it's very, very important because the data flow actually shows you. Now, remember, one of the standard rule in any software development is that there must be always an input and there must be also a corresponding output. That means that you can have 1, 1, you can have 2, 1, you can have 1, 2, as the case may be. But the most important thing is that so far as there is an input, there must be what? An output. So we actually use the data flow diagram to showcase or to show how data comes into our system and what leaves our system after it has been processed. Very simple. It's not a rocket science. Now the objective of a data flow diagram is to show the scope and the boundaries of a system. Remember, every software project is seen as a system, not a system as in hardware. I've emphasized this over and over again. Is a system because there is supposed to be an inflow and there is supposed to be an outflow and there is supposed to be a processing. That means it's supposed to do something. So it actually is a system because it will always have components. Component makes up a system. So we use the data flow first of all to define the boundary. The boundary as in how many input is it supposed to have and how many output is supposed to have. We also define it as when it gets to the next level, define the behavior of the system. If the system is supposed to process something or accept data or store data, keep information, at what point is it supposed to receive the data and what is it supposed to do with the data? It is expected to unpack it. When the system unpacks it, what is it supposed to do? What are the possibilities that comes out of that unpacking? That is, we can actually use a data flow diagram to represent all of that. So of course the essentials of data flow, you have the names should be unique. Okay, remember that data flow is not a flow chart. That is that is this thing. A flow chart is quite different from what do they call it, a data flow diagram. Data flow diagrams are more comprehensive, and they are in levels, grade by grade, as the case may be. Now these are the symbols of a data for data flow diagrams. You have the line. This is like a joining point, which is called the data flow. You can see what it does. Now this one, this is the oval shape. This represents the system, or the process. The rectangle tells you that this is an external entity. This represents the data store. So you can have how the data comes in and for storage, and then how it moves out, and when it moves out, what is it supposed to do. These are very basic symbols that we have. Now I've already explained this, so you need to read it up. Beautiful. Now the data flow diagram starts with the 0 level, which we usually call the context diagram. That is CONTEXT, context diagram. Now the context diagram, the simplest way to describe the context diagram just shows the inflow and the outflow. So you have an arrow coming in defining the input, and you all need to state the kind of input or the source of the input. Is it a keyput? Is it a user input, or another computer output? You have to indicate it. Then of course the circle represents the process. Then another arrow from the circle, facing right now, indicating an output and the kind of output. So that is what we call a context diagram. You will see it shortly. Very simple. Okay, I've already described that. This is an example of a context diagram. Now in this case, you have two input, x1 and x2. Then the circle, which is A, defines the system or the process, and this arrow defines the output. So we have two, in this context diagram, we have two input and one output. Now this is another way of representing it, so you can see how everything comes in. Okay, we are taking an example of a student results management. Okay, now the input will come from, yes, it's all input. The subject info is an input, the data entry operator is an input, student info entity is an input. Now don't think of this and say, why don't we represent all this in the context diagram? No, we may not necessarily do that. It's not necessary. Why? Because this is just context. That means it's supposed to just show the inflow and the outflow with no serials. So all the inputs of these, all the possible inputs are referred to as what? Input. Now the reason why we have two here is because the sources of input varies. There is this is a different source, this is what? A different source. Okay, so you are expected to understand. Is very straightforward, and you can see the output here. Now the next level is what we call the level 1 data flow diagram. Now this level 1 data flow diagram is also called what? The behavioral the behavior of the system. Why? Because it's not actually defining how the system is expected to behave. So it's a decomposed context diagram. So it will have multiple processes. It may have multiple circles, or not multiple circles, the entities and so on and so on, and of course sub processes and the unpacking of data and so on and so forth. This gives you a good idea of how it is. So you can see that it's a bit more complex. Why? Because you are now decomposing the context diagram. Here now you are trying to define some of the details of the system. Okay, an input. What kind of input? Is it entering, using the form to enter user data. Is it for registration? Is it for login? Is it for access? You are not breaking it down. Now, when it gets into the system, what is the system supposed to do? Does it need to connect to a database? If it's to connect to a database, how is it expected to connect to a database? When it connects to the database, what is it supposed to do when it connects to the database, which we call the data store in this within the data flow environment? When it connects to it, what is it supposed to do? Because the moment you get into a database, a stored data, you're expected to retrieve, and if you retrieve, what are you supposed to do with it? What is the content of the data? Is it a username and password is checking, or is trying to upload or rather insert information into a table? You need to define all of that, and it has to be shown within the diagram. Then the level 2, of course, the level 2 is more detailed. Every process, one of the things about analysis in software is that everything has to be taken to logical conclusion, but you don't start with that. That is a side effect of a data flow. Not data flow, now flow chart. If you are to have a flow chart, that means it will become more and more complex, because you now have to break everything into small sub-processes. Why? In your analysis, one of the things you need to do if you want to do detailed analysis, that everything must be taken into logical conclusion. For example, if you are working on a system that requires users to log in, that means that they have to enter their username and password. There are certain things you have to do. For example, you have to, the username and the password has to be correct. If it's not correct, what's the system supposed to do? You have to show what the system is supposed to do. Then if this username and password is correct, what else is it supposed to do? Everything has to be defined. So you take it into logical conclusion. In this case, as you can see, it's now broken down. You have the user account maintainers here. What the user, sometimes it's just a click of button at the end of the day when you implement it. But before you implement it and it becomes just a click of button, you have to show it this way, the way it's supposed to be. Let's give you an example. This one, the login is very easy to understand. You have the system, the person enters what? Data entry, enter what? User ID and pass this thing. So it comes there, okay? Now the system, of course, will retrieve. We have to connect to this. Then it retrieves the what? Information about the user. All right. Then it checks it. Okay. Enter user, the administrator. Okay. Now in this case, they have how many users? The administrator. You also have the conventional user, and you also have the coordinator. So all of this is for login details. Everybody requesting for it. But then if I want to take this to logical conclusion, each of them, when they request for it, from here it gets connected to this, then retrieves it back to this, then it unpacks it to know what it's supposed to do. All right. If it's not correct, if I don't see it in this place, I'm expected to prompt the user to enter what? Username and password again, and until the person gets it correct. I can say that, okay, after 3 times, if the person still do not enter the correct username and password, you should throw the person out and ask the person to register. You have the student information management system. You have it here, the subject information. So please kindly study all of this, and then you will need to do that. Now, time for demonstration. Now, for me to demonstrate, I'm going to be using an application called SmartDraw, because I'm comfortable with it. It's already in my system, so I can use it. But you can decide to do even eDraw Max. There are several tools, computerized tools that enables you to do analysis and design. Okay, so where is my Smart Draw now? Smart Draw. Where is my Smart Draw? Okay, here it is. So I just double click on this and wait for it to take. It may take a while because I've not opened it in a while, so let's just be a bit patient. And then Smart Draw. All right, this is great. Now this is a Smart Draw environment. It's beautiful. Every tool you need, you can use it. Now this is your, what we call, do I say the menu? If you scroll down, now it's not every computerized aided system engineering that you have things like this. Okay, of course it varies depending on which one you are using, but in this case, let's go to this. Now if you go to software, if you click on software, you can see that you have UML. UML is mostly used for what do they call it, object oriented, but that does not mean that you can use it for any other thing. Now we'll go to data flow. Now if I click on data flow, as you can see, these are data flow examples. I can decide to pick a plain one or click on any of them and modify it. What I do usually, I just click on this. Let me just modify it, create it from the beginning. Now these are the symbols that you'll be using. These are the external entities that you'll be using. This is the system. Okay, this is the source. If you scroll down, you see several of them. The processes, you have a interface. Okay, beautiful. Sometimes the smart panel may not show you everything, so you can click on the library, then you have that. I can also click on this and say more. If I click on more, I can come to this place. If I don't see a particular symbol I want to use here, I can come to this place, look for what I want, click on it, and it adds to the library. Okay, let me just quickly show you how to do a context diagram, then we move on to the next stage. Now to get it, I need to get the title of this, so let me say, what's my title? Let me just use an example. What example now? What example? Okay, music upload website. Let me say I want to design, my project is on music upload. I want to design a website or an application that enables users to upload music. They can upload their music, then their fans get there, download it, and so on and so forth. So my context diagram, I can give it a title. Let me move this way a bit. All right, can I even minimize it? Let me see. Okay, let me just, what's this? Minimize. Beautiful. Minimized it. So I'll come to this place. I can, this is my text, and I come here and I say context diagram, context diagram for music upload app, something like that. You can actually correct it if I click here. So I can click on this, come to the, make it bold, make it bold, increase the font as the case may be. can drag it here. I can change, still increase the font, right, underline it if I choose to. Okay, so here now I'll just click on this, drop it here, extend it, then I come to this place. If you click here, there is a straight line, there is this thing, I need a straight line, so I just draw it from here to this place. Okay, then go back again and I draw another line. Yeah, that shows this. So click on it. Here now, if I double click, I should be able to type. Let me say user input. Yeah, I'll say this is the system. Double click on it. I can say music or music upload app, so I can call it MUA. That is music upload. Come here, double click on it. I can say the output will be displayed let's see music download, something like that. All right, so it's as simple as that. So this is my context diagram, very simple. There is just one input, that is user request. I can even say user request, something like that. If I double click on it, let me even say user request. All right, so the user request could be to download, to upload, whatever. So here the output will be download or display successful, and so on and so forth. I can even say that, okay, let me use another one. Another output will be display. Let me just say display. That's it. So this is what my context diagram. So I'll save it, then I can save it inside and say MUA context diagram. Context diagram. I can save it like this, so it's saved. Now the beautiful thing about this Smart Draw is that I can decide to import this, or rather export this to Microsoft Word, as the case may be. If, for example, I come to this place and I say export to Microsoft Word, I can open Microsoft Word. Let me open one and show you an example. Sorry. So I'll go back to my Smart Draw and then I just say export. Now it has been exported to this, so I can increase it the way I want it. Now, but for me to edit it, if I made any correction, okay, I still have to go back. If I double click on this, if I make any error here, if I see any error, I have to go back and correct it here. Okay, now let's go to the next one, which is also very, very important. Let's see how we can we can move on to the data flow level 1 diagram. So I'll just say I've saved this already, so Control N for me to create another one. I'll go to this. Now sometimes it might be necessary for you to have a sketch before you start. so that you don't take so much time trying to figure out what you want to do. But personally, I don't so much like that, because to me it's as good as, so far as I know what I want to do, is straightforward for me. But as a starter, I would advise that you put down a sketch, just sketch some things down, and then you can start. That will save your time. Let me say MUO DGD level 1. That is the music upload. Sorry, it's supposed to be app data flow diagram level 1. Just like what I did the previous time, increase the font if I choose to. Sorry, it wasn't selected, so let me select it and increase it. I can make it bold. I can change the font if I choose to any other one. Ctrl Z. I don't want that. Let me just increase it to 20, and I can lift it whichever way I want. Okay, so let's start again. Go to the library. I have my system here. Okay. So I have my input here. This time around I'll start using triangle. Oh, my external entity comes here. Okay, so I'll come here, I take it to this place. Okay, sorry. Now you have to be careful, preferably if you want to use mouse. So I come here, I'll say user request. Okay. So here I'll say click. Let me say click up. So that's a user request. When the user request comes in, it needs to unpack. Okay. Service request. Let me just write service request. Now you have to keep adjusting as the case may be, and of course I need to also reduce the font of this, because if not it will get too big. Okay, the one inside I can leave it. Okay. Now this will unpack. This will unpack. Unpack request. That means it will now break it down into this. So when it unpacks it, it may be it could be, let's say, login request. It could be login request, login request. It will also be, it could also be let me say connection. It could also be login request registration. Could also be registration. Okay, so let's say that that's the first thing. So if it's a login request, then you will now have what they call, if it's login request, sorry, it will now connect to a database. Where is the database? This thing now, the data store. Okay, data store manual, data store automated. Let me just say data store. To now connect to the data store. So this is not even the right symbol for data store, although we can use it, but can decide to change it. Let me go to more, and then I'll look at let me see, sorry, I'm trying to get the okay, I think this seems to be more appropriate. This should be it. Yeah, this is more like it. So it requests for the data, request for data so if it's also this, it will also connect to what? Let me take this way, because both will seems to connect to data. Let me separate it. It will be better for me to separate it. I can duplicate it. Why? The reason why I'm separating it is because the way, yes, it's the same data store, but the way this will respond is quite different from the way this will respond. So this comes to this, then from this it can now display another entity. Let's say it grants it access. They give you access to page. So this now becomes maybe, let me say, menu page, for example, menu page. But then that is if it's correct, or else it may also go back and say, let me now use the curve. It may go back from here and say that go back and say user not found, user not found. All right, so then from here it can go back. From here it can now go back to here it stores it, and then it tells you successful. Let me come to display. Let me just use a curve. Makes my life easier. Okay. I think that's it. Okay. So nothing's that. So you say success. And you can say login page. This login page, then it now gets the person enters login page, and then the person enters this. The case maybe send login details. Okay. If this is not successful, it goes back. Alright, so this is an example of level 1 diagram. So you can do it this way. It's quite simple. It's not a difficult thing. Now, after doing all this, the next thing is that there is what we call entity relationship diagram, which you need to understand. Description process. Let's go to description process. Now, description process basically discuss the various processes associated with one software project. You should be able to do that. You know what a software is. Okay, set of instruction in the form of programs to govern the computer system. A software is just a collection of several programs. Now, the software development in this process, for software development, you have processes such as designing, programming, documenting, testing, bug fixing, and so on and so forth. That is all of it. Now, components of software, you have the program, you have the documentation, you have the operating procedure. Now, this is a step-by-step instruction compiled by the organization to help workers to carry out the complex routine of operations. So how the software is supposed to work, who is responsible for what, if there are issues or if there are user difficulties, who are they supposed to contact, and so on. You have all of that documented in it. But this is not even my area of concentration, because you can actually read through this and understand. Now let's go to data modeling, because data modeling is closely associated with the data flow diagram. Now, for data modeling simply means we are modeling something. Okay, we are trying to bring up something, a representative of what we are trying to do. Now, there is what we call entity relationship diagram, which has to do with data modeling, because you need to define the relationship that exists amongst tables. In programming, more often we always talk about the back end. The back end is actually the interaction between the front end and what goes on behind the scene. Is it manipulating data? Is it requesting for data? How do they get the information to display for users to see? Even if it's just a picture, the picture has to be somewhere for you to access it. And no user wants to go through the hassle of, okay, let me write a code in order to get that. No. They just want to get it at a click of button. When you click on the button, you want the image or the picture to appear. You want your interface to appear. So there has to be a relationship. You need to create that link, and that is what the entity relationship does for you. It helps you that, okay, I want to create tables. What kind of tables am I going to create? Is it going to be relational? If it's relational, I need to identify the field name, which attribute will I make as primary key or foreign key, in order for these things to work, to be able to relate in a unified way. ER modeling is data modeling method using software in order to produce a conceptual data model of information system. Diagrams are created using the ER model method are called entity relationship diagram or ER diagrams or ERD, as the case may be. So you are now saying that, okay, I need data, but I need to model those things. Now the purpose, of course, is for database analysts to gain, you need a better understanding of how the data is contained in the database and how the data can be retrieved. And then, of course, if a particular table is dependent on another table, how will it be able to retrieve it, and so on and so forth. ERD serves as a documentation. Finally, is used to connect the logical structure of the database to user, which is true because your interfaces must be connected to the database, or else when they click the button, nothing is going to happen. So it's very important, very easy. The components, you have the entity, you have the attributes, and of course you have the relationship that exists. So if you can read on what an entity, of course the real one, an entity, for example, if we were to look at it from the aspect of object-oriented, an entity can be a class. The class will be like student, okay? Subject is also a class. So the question now is, if I have student, I have a database called student. Now the table, rather I have a database and one of the tables is called student. So the table now, the student table will contain all the student details. Then I also have another table called course. All right, the courses or the programs that they are doing. Now this student detail table must be able to relate with the program table. Why? Because it's students that take the program. Then I can have another table called lecturer or tutors. Now the lecturer must also relate with the student and relate with programs. The program table via the what? Via the student details table, because the lecturer do not actually take programs. They may depending on the terminology, okay, let me say modules. All right, modules. If we have the module table, a tutor will interact with the student details table and also the module table. So there has to be a relationship. So these entities are actually very easy to identify depending on the programming language you are using. If you are using objects, if you are using Java, for example, just know that all your classes by default are entities. So they should have what tables created in the database that you are going to have. Then of course you have the entity set. Let's go on. So here, very easy, like I said, you say employee works for what? A department. You can say a student belongs to what? A department. So you can say that Eunice belongs to what? The computer science department, or John belongs to the what? The computer science department. Don't complain that I'm using Eunice. Is she not a brilliant student? Okay. All right. So now you have the field names. Now the field names are also called attributes, and these attributes translate to what we call variables when you are programming them. So a student, for example, will have attributes or field names like a student table, the student detail table will have attributes or field names such as name, address, ID number, which is your matriculation number, date of birth, and so on and so on. So these are called what? Attributes. They are either called attributes or they are called field names. And when I'm actually coding, if I'm to implement this in a code, this name, address, age, and ID number will be declared as what? As variables. And of course I will define the data type. This will be a string, this will be a string, this will be an integer. I can decide to make this an integer or alphanumeric, which is a string. Now, very, very important, when you are defining this, especially when you are creating the tables, the field names, or the attributes, there is also what we call data. You need to also define the data type. You should have done that in your database class. You need to, if you forgot it, please go back to it and do a refresher course there. Refresh your memory is important. The reason why I'm emphasizing is this, because the data type you use for your database, okay, must be the same or similar to when you're actually implementing. For instance, here now I can use VACA2 as for name. So when I'm now programming for name, I'm declaring name as a variable. I'm going to declare this as a string. If you declare this, if you created this as an integer and you're now creating this as a string in your program, it won't tally. It will always give you an error. It will tell you that you have entered the wrong value. So note that if it's a string, you must use the corresponding string version of it when you are creating the attributes within the table in your database. Okay, sorry, this has moved. Let me take it back. So let's go on. Not much of it. There are 4 types of attribute. You have the key attribute, composite. Now this, you should know this within your database course, so I'm not going to explain that. I'm not going to explain this either, so you read it up. Now for everything, now this is important because you're expected to apply the knowledge you've gotten here in your work. So let me show you how to create let me show you how to create an entity relationship diagram. Control N. Oh, have I saved? Ooh, sorry, I have not saved that. Let me just save it. I think I've already. Let me see what I've done. Do you want to? I want to save it. Let me save. No, I'm not so sure. Let me close this first. Okay, it's back now. So let me save it. Let me say MUA DFDL1. Save it. Alright, Control N now. I'm going to entity relationship diagram, so I'll just scroll down, go to software, where is it? So I click on entity relationship diagram and I just click on this. Now when you are doing your entity relationship diagram, now using SmartDraw may not be the best, even though SmartDraw has the tools What I use for entity relationship diagram is what I call MySQL Workbench. If you go on the internet, if for example you go, it's not installed on this system, so that's why I'm not using it. If I say Google and I say MySQL Workbench, for example, you can download it. It's very easy. Let me see if I can even use the online, because MySQL Workbench. It wants me to download. I don't want to download. Let me see if I can say using MySQL, using MySQL online. Is what I was looking for. Oh, they want me to pay. You know that I won't pay. For what now? Why should I pay? Let me see if I could get something around it. Oh, still wants me to download. I don't think I want to do that. MySQL Workbench makes it very easy. I'm not sure if I'll be able to use the other system to demonstrate it, but it's very easy. All that is required of you is just to create it. If you have, if you install what we call XAMPP, if you go to Google, and you XAMPP download, for example, XAMPP download. Okay, if you do that, you can download it and then use it. I already have it on my system, so let me just demonstrate something to you quickly. Let me minimize all this. If I go to my computer, go to my hard disk, and then I go to programs. No, not programs, XAMPP, because I did not install it. I just downloaded the I prefer to extract it and drop it in my C drive instead of keep installing and installing. So I'll just go to this place and click on this. Because I did not install it on my system, I have to manually start it. Now if I double click on this, this tells me that it has started. Okay, so I'll now go back to here to confirm. If I now type localhost, for example, it should come up with no beautiful. So this comes up. So your database, you can actually create it. Then I go to my phpMyAdmin, click on it. If you click on phpMyAdmin, wait for it to come up. It's taking so much time. Alright, I have this. So here you can actually create your database. I already have a couple of databases. So here now, this enables you to create your database, all the tables that you want, without necessarily knowing SQL statement. You can easily create it here. The moment you create it and you define it, all right, you can now export it to MySQL Workbench. Now the MySQL Workbench is what enables you to, is a designing tool. So the moment you export it, because you've already created the identify the tables, the attributes, all the relationship that exist, it automatically just links it up and gives you beautiful this thing. It is quite easy, very easy. So you can try out MySQL Workbench. But let me look at this. I want to check if I could import or something. Let me click on this. You know, one of the things that you must learn how to do is to make life easy. So let me say I want to import. Let me click on import. Okay, visual, convert visual to this. Okay, maybe let me do something here. I want to where is my, okay, let me see. I have a couple of things here. Okay, I think this is something that I have done very well. So if I click on this and let me see, there used to be one icon. Panel setting. No, databases. This is not it. It's easier with what did they call it? MySQL Workbench. Let me check. I'm sure I should have a database somewhere. Okay, my admin. Let me see if I'll see. Example. No. I'm trying to check if I'll see database here. What I have done so far. I'm not seeing it yet. Let me move a bit backward. MySQL. Okay. I think this probably may give me what backup. Let's see. Can I see the database DB? No, I'm not seeing it. Okay. Is it DBA or what? Let me check the name of the database. ADB. Okay, it's ADB. Let me see if I'll see any database like ADB. No, it's in alphabetical order. ADB. No. This is getting. Oh, I don't like this. Okay. I thought I could get a shortcut, but it's alright. So let's go back to our SmartDraw homepage. So this is it. I'm going to okay, so this will be here. Alright, then I can have empty this. Change this to the page layout to change the orientation to landscape. Alright, it's easier for me to so you have this, so you can say student belongs what department. So you have your go back to here. So okay, now yeah. So this defines the relationship, very easy. But then sometimes there is what they call a database schema. The database schema means that you now have to have your tables for each of them with the attributes, the data type, and show how each table relates to the other. I think you can also do that in Access automatically. If you define the primary key and the foreign key, you can do that. So it's very easy. But this is a very simple way of showing your entity relationship. But I believe that I should be able to show you how to do it using Workbench, MySQL Workbench. I pray I'm able to download it and then show it to you. I hope you've learned something. Please kindly go through the video, this lesson over and over again. Go through the slides over and over also, so that you'll be able to understand most of the concepts that have already been taught here. All right. If you have any questions, you can send me an email or just put it down when we meet in class. You can ask me, but don't ask me about questions for the exam, because I'm already setting your exam questions. Thank you very much. Right.